Good day and welcome back to Maths Mastery Event. Of course, we make maths simple and fun. So today we're looking at differentiation. But before we begin, kindly like, comment, and subscribe to my channel for more maths mastery. Okay, now let's get straight into the business for the day. So we have differentiation, and students normally find it difficult when solving questions under differentiation. And I'm going to make it very simple for you. So before you understand how differentiation works, you need to know the rules of differentiation. So you need to know how to use the rules, when and how to use the rules. Okay, so now let's look at the rules of differentiation. So we have the first rule to be the product rule. So we have the product rule, we have the quotient rule, and we have the chain rule. Okay, so now let's take them one after the other. Let's see how the product rule works. So now the product rule, so you need to know the formula, you need to know how and when to use the product rule. And the formula for the product rule is, we have u multiplying the v dx plus v multiplying the u dx. Okay, so this is the formula for the product rule. And as I said earlier on, the question won't tell you to use the product rule, the quotient rule, or the chain rule. But with your understanding the differentiation, you should be able to know which formula to use and when to use them. Okay, so now let's look at some example, and I'm going to explain the product rule, how the product rule works when we are solving a practical question. Okay, so now let's begin with the questions. So we have an example one. So let's look at this example here. So 2 multiplying or 2x plus 3 multiplying x to the power of 3. So in case you see any similar question or any question in this form, so you can see we have two functions multiplying each other. So we have this one in one bracket and this is also in another bracket. So if you see any question in this kind, the formula or the rule we are going to use is the product rule. Okay, so now let's see how it works. Now, okay, so let me break it down for you. So we have the question here. Anytime you see a question of this kind, please take note that the first one here is your u, and the second one is your v. So anytime you see any question of this kind, please take note that the first one is your u, and the second one is your v. Okay, so now you know that your u is 2x plus 3, and your v is x to the power of 3. Now let's differentiate this functions here. So now our u. So if you want to differentiate u, we have du with respect to x. Why is it with respect to x? So we know that the function here is u. So we have u 2x plus 3. And we want to differentiate with respect to the variable here. So that is x. So let's say you have a 2b plus 3. And you want to differentiate a. So you are differentiating with respect to b. So now you have the a over the b. And that is how it works. So anytime you see a function, let me give you another example. So let's say you have x and then 2y plus 3. So anytime you want to differentiate, it is the x with respect to the variable in the function, that is y. So the x is y, and that is why I wrote the u dx. So now let's differentiate this function here. So if you differentiate 2x, you are getting 2. And the reason is, anytime you see a question, so let's say you have 2x, or let me bring an exponent of 2. So anytime you see a question and want to differentiate, please take note of this. You are going to use the power rule, and this is how the power rule works. So we have an exponent of 2 here. So the power rule is saying that this 2, multiply this exponent by a coefficient of x. So when you multiply 2 by a coefficient of x, subtract 1 from the exponent here. So we have x 2 minus 1. This is how the power rule works. So we are getting 4x. So 2 minus 1 is 1. So you can write it as 4x to the power 1 or 4x which is the same thing. So that is the same thing I did here. So 2 is multiplying x. And in this case, x is carrying an exponent of 1. So we have 2x, so 1, right? Okay, so if you differentiate this, you are getting 1 will multiply 2. So you say 1 times 2, right? And you have the x, so x will be, so the exponent of x, you subtract 1 from the exponent, and you are getting 1 minus 1. Please, okay, so when you are differentiating, you are not going to differentiate everything straightforward. You need to, so you take this, and if you see any operation, you pause, and then you differentiate this, then you differentiate the other one. Okay, so this is what I've done. So we have the 1 multiplied the coefficient of x, and then we subtracted 1 from the exponent. And you are getting du dx is going to be, so 2 multiplying 1 is 2, and x raised to the power 1 minus 1, you are getting x to be raised to the power 0, right? Okay, so at the end, du dx is 2. Now, I know someone will ask why I don't bring the period. Normally, when you are differentiating a constant, so this is a constant. So anytime you are differentiating a constant, the result will give you 0. And this is why the result gives us 0. So anytime you see a constant, so let me use that period. So anytime you see a constant, we assume that x is raised to the power 0. So we assume this is the assumption, and this is the logic about it. So anytime you see any constant, this is the logic about it. And from this, you are going to use the power rule, right? So the 0 here will multiply the 3. So we are getting 0 times 3, isn't it? Okay, so now this is the first thing we've done. Now x, 0 minus, so we subtract 1 from the exponent, and we are getting 0 minus 1. So if you multiply this 3 by 0, we are getting 0. And everything, in fact, everything here will give us 0. And that is why if you differentiate a constant, you are getting 0. So now we know that our du dx is what? 2. And our u is 2x plus 3. Now we solve for the du dx, and we know our v. Sorry, we know our u, and then we know our v. Now it's left with this one. And with that, we are going to differentiate the v. So the v, so we are differentiating v with respect to what? X. So the v dx. And with this, we are getting, so as I did here, x is raised to the power 3. So if you want to differentiate this, the coefficient of x is 1, right? So if you want to differentiate this, 3 will multiply the 1 here, so we say 3 times 1. So 3 times 1, x, so we will subtract 1 from the exponent, which will be 3 minus 1. Okay, and then we are getting the v dx to be, so we have 3x squared. Okay, so that is it. So now we have our u, our dv dx, our v, we have our du dx. Okay, so now let me clear this part and continue from there. Okay, so now we know that our u is 2x plus 3. Please, if you want to make it very simple for you, this is how you go about it. So we know that your u is 2x plus 3. Our v is, so x raised to the power 3. And our du dx, we had 2. And our dv dx, we had 3x squared. Okay, so now we are using the product rule. And this is the product, so u, so that is why I already did this way. So we know that your u is 2x plus 3, v x raised to the power 3. And then differentiation. So we know the u dx to be 2, the v dx to be 3x squared. And to use the product rule very simple, you are going to multiply the u here by the derivative of v. So we know u dv dx, right, plus v du dx. So this is going to multiply this is going to multiply this, right? So now we are getting 2x plus 3 multiplying 3x squared. So So now this is the first one we done. So now these are the dx. So plus, there's plus here. And our v is what? X to the power 3 multiplying our du, which is in this case is 2. So now this is our v, this is our du dx. And that is how the product works. So from this we can break it down. So we have this 3x squared multiplying 2x plus 3. So if you multiply 3x squared by 2x, we are getting what? 6x raised to the power 3. So in this, so we have this x raised to the power 2 and this x raised to the power 1. So when you are multiplying, you add the exponents and we are getting 6x raised to the power 3. Okay, and then we have again 3x squared multiplying 3, we are getting 9x squared. Right. Okay, so plus this plus here. If you multiply this, so 2 multiplying x raised to the power 3, we are getting 2x cubed. And in this case, you group like this. So we have s cubed, and that is giving us 8x cubed plus, 8x raised to the power 3 plus 9x squared. And that is our final answer. And this is the solution for the first question. Now let's look at, I believe you understand this very well. Okay, so if you understand, give a different example. Okay, so we have example 2. So the next example, we have 3x squared plus 2 multiplying 2x plus 3. Okay, so this is a different example, and let's see the solution for that. So we know that our u is the first one, and then our v. So now you know that u is 3x squared plus 2, and our v is 2x plus 3. Right? So now let's differentiate this. So we have the u with respect to x to be. So if you differentiate this, 2 multiply the coefficient to 2 by 3, and then you subtract 1 from the exponent. So you are getting x to the power 2 minus 1. And because this is a constant, you are getting 0. So our final derivative will be 6x, because you are getting 2 minus 1, which is the same as x to the power 1, or you can write it this way. Now let's differentiate our v. So the dx, we are getting, so this is similar to what we did. If we differentiate this, 1, the x is carrying an exponent of 1, so then 1 will multiply the coefficient, so we are getting 1 by 2. And x raised to the power 1, we subtract 1 from it. Because there is a constant, we are getting 0. And at the end, our derivative is going to be 2. Right? Okay. So we have this. So we have the u, we have our du dx and the v dx. So we know that our u is equal to 3x squared plus 2, and then our v is 2x plus 3, right? And the u dx, we have 6x, and our the v dx, we have 2. So you cross multiply, and you use the rule. Now, if you cross multiply, you are getting 3x squared plus 2. Multiplying the 2 here, plus. So we are using the formula. So we have the u multiplying the v dx. So u, and then this is the v dx. Right? So our v, that is 2x plus 3. Multiplying our u dx, that is 6x. So from this you can simplify. So 2 multiply this bracket here, and we are getting 6x squared plus 4. Right? So this plus here, this operation plus, this. So 6x will multiply this bracket as well, and we are getting 12x squared plus, if we multiply 6x by 3, we are getting 18x. So you have group like this. So we have 6x squared plus 12x squared plus 18x plus we are getting, so if you add this and this, we are getting 18x squared plus 18x plus 4. And that is our formula, or that's our, so that's our solution for the second question. And I believe you understand, you now understand the product rule. This is how you go about, this is how you use the product rule. And anytime you see a question in this form, please take note that this is how you are going to do it. This is how you go about it. Okay, now let's move on to the second rule. That is the quotient